Hello and welcome everyone. This second Tech Talk on IEEE 802 networking standards today is focused on the 2020 Ethernet bandwidth assessment. My name is Jennifer McLean. I'm a senior product manager with IEEE Educational Activities, and I will be helping moderate today's event. IEEE is the world's largest technical and professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable so you can move them around to make the most out of your dashboard space. If you have questions for today's panelists, you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen, and we'll answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about 802 standards and past and future virtual events. Finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEELearn. Maintaining an ongoing understanding of industry bandwidth trends has been beneficial to the Ethernet industry. Such knowledge has been highly leveraged to help determine the time frame for the availability of the next higher rate of Ethernet. The results of the latest 12-month industry study undertaken by the IEEE 802.3 Working Group was published this April in the 2020 Ethernet Bandwidth Assessment. The technical standards created by the IEEE 802 Local Area Networking Metropolitan Area Network Standards Committee, or LMSC, over the past 40 years have been essential in enabling suppliers of data communications, components, products, systems, and services to be delivered economically and at an immense scale. Our panelists today are Paul Nikolic and John D'Ambrosio. Paul is chair of IEEE 802 Landman Standards Committee, overseeing 75 active technical standards and the 50 concurrent projects for wired and wireless networking applications. John D'Ambrosio is a distinguished engineer at FutureWay, a U.S. subsidiary of Huawei. He is a member of the IEEE 802 Executive Committee and chaired the last 2 projects that developed the next higher speed of Ethernet. And now I'll turn it over to Paul to get us started.
Thank you very much, Jennifer. Before we get started, I just want to mention that the views that we will be sharing with you during this Tech Talk belong to John and myself and don't represent the IEEE Standards Association's perspective. So with that out of the way, let me start by saying what the mission of the IEEE 802 Landman Standards Committee is. Our objective is to develop high-quality, market-relevant networking interoperability standards that have been deployed globally over the past 40 years. The standards development work that we do is done by almost 1,000 volunteer networking experts from all over the globe as well. 2 physical layer technologies that are standardized by IEEE 802 are based on wired and wireless media. While many are familiar with connecting wirelessly to a network over Wi-Fi, which is based on the wireless local area networking standards that are developed by the 802.11 Wireless LAN Working Group, they may not be as familiar with our IEEE 802.3 Ethernet Working Group that has developed the interoperable networking standards for copper and optical wired infrastructure, which connects wireless devices to all the internet applications that we use today. And one common driver uniting both wired and wireless technologies is the thirst for bandwidth. One common theme has been the constant increase in bandwidth needs. So, John, why is understanding bandwidth requirements so important to IEEE 802?
Thanks, Paul. There's a lot of really interesting reasons here in terms of why bandwidth is important, not just to 802, but to actually the consumer. right? You think about the types of things that you're going to do, and what's one of the things that you have to do every month? Well, you got to pay that cable bill and pay your internet access. And knowing how much bandwidth you need is a real financial justifier to the consumer. They may want to have a faster pipe to their house if they're going to be doing a lot of high definition videos, or if they have a lot of people in their house, right? So they may also be working from their house. They may be doing, in today's COVID-19 world, a lot of video conferencing. Understanding all of these to the consumer is actually very important. And that's a really good analogy to then make to business, right? So understanding what the bandwidth demands are and will be allows us then to justify the different efforts, as well as help us to set the goals of those efforts for the different standards that we're going to build. 20 years ago when I got started, the world was transitioning to 10 gigabit. Today, we are at 400 gigabit, and based on the bandwidth demands that we're now seeing, we're realizing that we're going to need to do it again. And as the applications get bigger, for the wireless community, they need to understand, well, what's the consumer going to be looking for in terms of a wireless connection? Because that's how, as you mentioned, that's how a lot of people actually get onto the internet nowadays is through the phone. Matter of fact, by 2022, it's predicted that almost half of all of the internet IP traffic is going to be to your phones. Where in 2017, it was computers. So there's a huge transition here, and all of the supporting technologies that provide the network to the end user today need to be thought through and understood in terms of what does this mean to the different products and networking standards that we're going to need to develop in terms of speed. And there's a lot of technical decisions that then are impacted in terms of what you would do. Going one speed versus another speed can have very significant technical complications that need to be considered in terms of, what is the right solution.
Fantastic, John. That's an incredibly high growth rate that you've stated over the past 20 years or so. So clearly monitoring the growth rate of network requirements is an important feature that you must pay close attention to. So you, as a member of 802.3 Ethernet Working Group, how have you monitored the bandwidth needs growing over time and projecting where they're going to go?
Well, that's a good question, and I would like to say that we understood from day one that was the case, but it wasn't. A long time ago, back in the early 2000s, Ethernet had this mantra of 10 times the performance at 3 times the speed, and we always grew at a 10x increment. In 2006, I started the effort to go beyond 10 gigabit per second. And during the course of that effort, there was a lot of debate in terms of what the next speed should be, all right? And what wound up happening was people who were talking about networking were noticing a large growth in traffic where going 10x, jumping to 100 gig, made a lot of sense. But for the community at that time, the server community, which really, in terms of, you think about volume, there's more servers than networks in a lot of cases, right? Because that's all the end stations. Making that 10x leap didn't make sense for the server community. Servers were growing at a different bandwidth rate. And we realized as a result of this long debate, and that effort, a little bit of trivia in 802.3, that 2006 higher speed study group is the longest study group on record. And it's a dubious honor, of course, to have that, but it also was a teaching moment for myself. And we realized that understanding the importance of bandwidth, it was such an important factor in that study group that it led to the decision to do 40 gigabit and 100 gigabit. And we realized that we needed to keep monitoring this in order to be able to move quickly so that we didn't get into the same debates in the future. So after we completed that project and developed 40 and 100 gigabit Ethernet, we kicked off an effort to start a bandwidth assessment in 2012. And we realized very quickly that there really is a very simple equation, which I'm showing here, in terms of understanding what can cause a bandwidth explosion. It's actually very simple. It's the number of users that you have times the devices and the access rates of those devices times the different applications that you have. Now, you'll note there's three factors to this equation. Any one of them or any combination of them can actually drive a bandwidth explosion. And it's not a uniform globally. So there are different factors globally that when you look at this, and you know, as I said, we did this in 2012. This was a very large influence in our thinking, and we basically realized the same thing was true when we did most recent bandwidth assessment, which we're talking about today, the 2020 bandwidth assessment, where it really is, once again, the users times the access times the applications. That really is a guiding factor. Now, the data that I'm showing on the screen right now is some data that I've pulled from the bandwidth assessment, as well as updated some of it because it's constantly changing, which is another dimension, time, that you need to look at. So we looked at, you know, just real quickly, the bandwidth assessment was a one-year information gathering effort. We looked at data from a bunch of different people, a bunch of different organizations, a bunch of different reports. The data that I'm showing right now is just a comparison between North America and Asia Pacific to help illustrate some of the differences and some of the similarities. You know, just going through this real quickly, in North America, there is 327 million internet users. And this was, I think this data was as recent as March of this year. And it keeps changing, so please keep that in mind. In Asia Pacific, it's 2.3 billion. All right, but what's really important to understand with that is that in terms of North America, we have a high penetration rate. So you're probably not going to see the same sort of growth by getting more internet users in North America as you are in Asia Pacific, which at 2.3 billion still only has a 54% penetration of their area. All right, so there's a lot of room to grow in terms of users. Next, you can look at access, and it's very interesting once again here. While they're both very similar in terms of their fixed broadband speeds, you can see a significant difference in both Wi-Fi and cellular. And the other interesting trend here is that from a cellular perspective, in 2022, it's predicted that cellular will be close to what fixed broadband was in 2017 for North America, while in Asia Pacific, that's not the case. You can see it still lags. The fixed cellular still will be lagging fixed broadband of 2017 numbers significantly. All right. Finally, the applications, and this may not be a huge surprise to people, but there really is one simple application that tends to just drive bandwidth: video, video, and more video. And it gets worse because, better, however you want to look at it, because of the shift to higher definition TV. So going from standard definition to high definition to ultra high definition to 812 and 16K. Very significant impact in terms of what that is going to mean. And by 2022, I think the numbers in the report show that it's going to be like 70% of all IP traffic is going to be video based. Okay, so you know there are differences and there are similarities, and that provides a really challenging dynamic in terms of coming up with solutions that meet the overall market when the overall market is varying quite a bit.
Very good, John. That's a very good summary of the work that you've done. Could you just say, you know, roughly how many people were involved in the work and roughly how long it took you to accomplish it?
Well, the number of users I would approximate at about 100 people. This includes the people who gave presentations. This includes the people who, leadership that led the project and the generation of the project. And then the report itself went through the entire 802.3 working group for review, and just like a standard actually does. It was actually validated. So we had probably about 100, 120 people who had their hands in on the document, looking at it, participating in it, and such. And I should point out that that's just the people who were directly involved, not the people who have been downloading the report. I mean, I keep track of that, and I think we've had 1,300 or 1,400 people have downloaded this report. So it really does wind up having a huge industry presence.
Excellent. Yes, it shows how authoritative the work is. I mean, this is work that's been done by, as you say, hundreds of networking experts using primary sources. So it's a very valuable piece of work that the group has done and will use. So, John, I'm going to also ask how you've got a slide. I'm going to be bringing up the next slide. This is a great slide which summarizes the various findings from the report. Maybe you can walk us through this slide. What were you trying to show with this graphic?
Okay, well, thank you, Paul. The prior slide, when I talk about the findings, we talk about the bandwidth explosion. I think the findings have to include the prior slide, which is the underlying pressures, the underlying factors are actually growing bandwidth. I should point out that information like that is actually more accessible, right? Getting bandwidth data is extremely challenging. You can imagine how a lot of businesses whose business is data isn't necessarily willing to always share all of that data. So we had to really gather our findings from everything that we could. Now, this data right here is really looking specifically at the equation, right? And by the equation, I mean what is the total? What is the network bandwidth growth, right? Because ultimately, Ethernet is providing these pipes. So we wanted to know how the pipes were growing. We took a number of different applications that we were able to get data for. Now, that data varied in terms of period of when they were actually accessible. So we only actually had a lot of data going out to 2022. So we had to make some assumptions and assume a constant growth rate, which in essence is not always true. The growth rate of a mature technology tends to approach a constant, but when you have new applications, such on this chart as virtual reality and augmented reality, you can see there's a lot of growth because it's a new application where the bandwidth reflects the adoption. Okay. This chart then summarizes the various applications that we were able to get data for, and then projects it out to 2025 to give us a 5-year roadmap from when this report was published, which was earlier this year, so that we had an idea where things were going. And in some ways, it's very scary, right? If you look at the peering application space, and peering is you can look at peering as the heart of the internet, where all the places come together and cross-connect in various places throughout the entire world. That growth rate is down in 2025 will be 2.2 times the traffic that it was normalized to in 2017. All right, and that's an important point here. This doesn't show the absolute traffic numbers because those traffic numbers are so vastly different. Data centers, the amount of data that they ship is just so incredible that if I were to put all of this on the same graph in terms of actual bytes, it would be, you'd be looking at a huge line and a low line. So it doesn't really make a lot of sense. So we just look at the growth rates, normalizing the traffic levels back to their 2017 levels.
Yeah. John, what's interesting about this graph, it's a semi-log plot. So on the vertical axis, you have it in log axis, which shows that a straight line is really exponential growth. And
exactly.
As we know, exponential growth leads to immense numbers.
Yeah, that's a great point, Paul. I mean, if you look at the 2025 scale, that number is actually varying from 2.2 to like 55.3, I think, were the actual numbers. Okay, that in itself is a really key point to make here, because it really does show the challenges with making one size fits all. right? Not all markets have the same needs and same demands, though they may share some of the technologies. I think this is one of the reasons why you see such a difference in pipes that people actually use. Some people, I've had people tell me, oh, I don't need a gigabit. And they may be right for their application. But when you look at massing and aggregating all that data, and you look at the core networks, and you start to look at data centers or telecom providers, or even 5G with its promise of near infinite bandwidth apparently for everybody, this causes a lot of pressure on pipes where there's going to be huge growth, and 400 gig today is going to have to grow in the future. Now this is a key point, and this is really where, from an Ethernet standards perspective, it's raising some red flags for us. If we were to assume that it would take 4 to 5 years, really 5 years, to complete a standard, which is based on history, a fair approximation for these next speed projects.
Excuse me, John.
Yeah.
When you say completing a standard, that's really completing an amendment to the existing base standard. So
Yes.
you're adding to the base, right? Okay.
Yes.
And that's like
that's a great point.
Okay, thank you.
Right. No, thank you for bringing that up. We keep building on the standard. There's a lot of technologies that have been developed that may be leveraged again. So yes, it is an amendment to the standard. It takes about 5 years. And I should point out that that's 5 years to develop the standard, not 5 years for the market to then have products. That can take a little bit longer. So if we were to increase to 800 gigabit Ethernet, which is one of the next speeds commonly talked about, that would only represent a 2x growth over where we were in 2017 when the 400 gigabit standard was completed. Some people have talked about 1.6 terabit. And that is a 4x representation. And people might say, okay, well, why don't you do 1.6? Well, A, what are the technologies that will work to develop this? And B, is it going to be economical? I had an end user say to me, they're not waiting for the next rate of Ethernet. They're waiting for the next economical rate of Ethernet. These things go hand in hand. Networking has really advanced as it becomes lower cost and more deployable in terms of cost, because we still have worry about that bottom line. So in 2025, 2x and 4x growth over where we are in 2017 is barely keeping up, and the actual products probably wouldn't be available for a couple of years after that. So these curves only get worse for what Ethernet will have to deal with, and this is why. Inside of the 802.3 working group, there's an activity that I share, the NEA, and we're actually working on developing a CFI, call for interest, to start the next speed project now.
So, John, tell us about one of the technologies that you are considering to use for this next generation Ethernet that has not been used in the past. I think you've mentioned it before, the coherent optical, I believe it was.
Right. There's a lot of debates that need to happen, and this is one of the other reasons why people want to get started. So normally you use a direct detect optical solution for a lot of the Ethernet standards. Actually, most of them. Two of the projects that I'm sharing right now, one is developing 100 gig to go 80 kilometers. The other one is developing 400 gig to go 80 kilometers. And both of these are leveraging technology commonly used in the telecom space called coherent technology. It's not the same. It's much more intense. You're sending more bits per a symbol than you normally do, which today is either a single bit with NRZ signaling or 2 bits with PAM4 signaling. So we are looking at this coherent technology. But that's not the only thing that's under consideration. Direct detect probably will not go away. There are people who are also talking about increasing the signaling from 100 gigabit to 200 gigabit. So this would be an increase most likely in the baud rate, and potentially another change to the modulation scheme to potentially send more bits per symbol. So a lot of debates that need to happen, and one of the other reasons now, this all goes hand in hand, and when we're developing a standard, we're looking at this stuff. What's the need? In this case, what's the bandwidth? How fast do we need to go? and from that question, it's like, well, how fast could be, how fast is the baud rate? How fast am I sending symbols? What's the modulation scheme? What is the fiber or the media that's going to be used? How many of that is going to be used? And in some cases, some people are even talking about, do we do full duplex on a single wire? Instead of having, you can imagine a lot of your typical solutions are by 4 in each direction. So you're sending 4 transmits in one way and 4 receives on the other. Some people are suggesting, why don't we use all 8 of those? So there's so many different technologies yet that need to be discussed before we actually start defining what the future standard will be.
This is what you're doing in the new Ethernet applications ad hoc, right, that you're leading. So you're
so much technical. The technical is really more a question of, well, what are some of the technologies that we may use? Using today's 100 gig technology, one can easily imagine doing 8 by 100, but that may not necessarily be the best cost. So we're having a question about that. We're also having a question about the speeds, right? So as well as what is the market demand, right? And why now? Why do we need to get started now? I look at this chart that came from the bandwidth assessment, and I remember the day that I came up with this. I was talking with some friends in the analyst area, and they were saying, "Well, we'll do this, do that," and I put it all together, and I saw this chart, and I'm like, "Oh my God, we don't have time. We need to get started." I mean, it was that obvious to me because of this growth, and that's really now what's happening in the NEA is building the consensus. That's really what the NEA is a consensus building forum. Building the consensus and defining the presentation that we will take to 802.3 maybe as soon as November of this year to get started on this. What would be the first leg would be a call for interest that would then lead to a study group where the full project would then be scoped.
All right, very good, John. So I'd like to take a little bit of a pause here and see if we have any questions from the people that are watching. Jennifer, do we have any questions?
Yeah, we have a question. Why are devices not included in the bandwidth explosion equation? Or maybe
okay, so yeah, they are. This is just a terminology issue here. We changed to make the equation more accessible. We went users, access, applications. It really is access methods and their data rates. Okay, so devices are included in there. That was one of the things that I was talking about in terms of how the PC and the phones are changing places. You've got to look at all of that together. So it really is included in there, just a simple simplification. Of what you will to make the equation more accessible. But it's a good point. And, I think this actually is time to make a very key point. Actually, 2 of them. So first of all, we're giving you a half-hour presentation or talk about something that took a year for information gathering and 6 months of analysis and writing. All right. So I would point to everybody in the backup slides. We do have references pointing to the actual bandwidth assessment. It's about a 60-page report for you to read. I would encourage everyone to read it. I would also point out that it's a snapshot in time, and this is a key point because all the data that I've shown here today that we've put up is pre-COVID. So the actual completion of information gathering ended in October of 2019. So from October to April was when we were doing all the analysis and writing. And the report was actually submitted for approval prior to the current COVID lockdown that we're in. Now, we didn't pull it into this presentation because it was really part of the bandwidth assessment, but on the last Tech Talk that Paul and I did, we talked about the impact of COVID, and what we've seen from COVID is double-digit growth in all of the various applications, where all the various applications out there in the ecosystem today. Just as an example, when COVID came in and we were doing a report on this, we were doing some quick searches, and one of the internet exchanges that I follow, it's one of the largest in the world, they experienced a 1 terabit per second day jump in traffic. Okay, now mind you, it's not like they were at 200 terabit already. They were like at 7 or 8 terabit, and they jumped to like 9. Okay, so it was an instantaneous change of bandwidth. And I think that's a really key point to understand as you're looking at that report is, wow, it was already bad before COVID, and we have seen a lot of applications get even worse. I know we've got hundreds of people who will look at this video in this pre-COVID world. This has become the norm. So there's a lot of more traffic that's being distributed through those normal networks. Just imagine the shopping that you're doing. Imagine all the streaming that you're doing. All of this is impacting the bandwidth as we know it today. So the picture that I painted right here on, oh, it doesn't jump. Got to go back. The picture that I'm painting right here, it's probably gotten much worse than what we're showing.
John, we have run out of time. We've gone over, as we tend to do. So at this point in time, I'm going to hand it back to Jennifer for the wrap-up. Jennifer?
Yes, thank you so much, Paul and John. We did answer a couple of the questions, and we can answer whatever. There's a few extras, and we can get back to those individuals after the session. As noted earlier, the on-demand link for today's event will be emailed to all registrants in approximately 2 hours. And be sure to register for our next IEEE Virtual Tech Talk on privacy's increasing role in technology. It is on August 12th at 9 o'clock Eastern Time, and you can find a link to register in the resource list. And before you leave, if you could please complete our survey via the survey tool at the bottom of your screen, we would really appreciate it. And once again, thanks so much to Paul and John, and thank you all for your time. Have a good day.
Thank you,
everyone.
Bye.